Plate Tectonics by Hope and Sophie.
Alfred Wegener was a German scientist, geophysicist, and meteorologist.
He invented the theory of continental drift. After realizing that the edges of continents fit together like a puzzle, Wegener proposed the idea that all land masses had once been connected in the supercontinent Pangaea.
Additional evidence for this idea was that glacier deposits were found on parts of the southern hemisphere, which showed that the continents were once connected and covered with ice.
The last piece of evidence is that the fossils Glossopteris and Mesosaurus were both found in the continents that are now very far apart, which points to the idea of Pangaea as well.
Now we are going to talk about continental drift. Eventually, the continents all moved apart from each other again. Wegener's explanation for this theory of continental drift was that the rotation of Earth created a centrifugal force towards the equator, which caused the continents to move. Wegener proposed that continental drift was responsible for mountains as well. He said that mountains were formed when plates hit into each other and pushed up. The edges of the land masses would fold up, creating mountains.
In addition to convection, tidal energy, or the pull of the moon, also moves continents to different regions. Wegener's ideas were rejected by most of the scientific community, but scientists Arthur Holmes and Harry Hess supported Wegener's theory of continental drift.
Their evidence was that thermal convection in the Earth's mantle could make tectonic plates move. Hess also made a significant contribution to the theory of continental drift when he discovered seafloor spreading, which is a process that occurs at mid-ocean ridges where new oceanic crust is formed through volcanic activity, then gradually moves away from the ridge.
Scientists Frederick Vine and Drummond Matthews added to this idea with new evidence about the magnetism of rocks surrounding mid-ocean ridges.
Now we are going to talk about the layers of the Earth. The Earth is made up of the crust, mantle, and core. The crust is the outermost layer and ranges from 5 to 70 kilometers. The thinnest parts of the crust are the oceanic crust and are made of igneous rocks. The thicker parts of the crust are the continental crust and are made of less dense rocks like granite.
The Earth's crust is 4 billion years old, but the ocean floor is only 2 million years old because of subduction. The mantle is the deepest part of Earth, extending to the depth of 2,890 kilometers.
The upper mantle and lower mantle are separated by the transition zone. The mantle is composed of silicate rocks.
The center of the Earth is the core, and it is divided into outer and inner. Both are mainly made of iron and nickel, but the inner core is thought to be more solid than the outer.
Plate tectonics occurs in the lithosphere, which is the Earth's crust and upper mantle.
Now we are going to talk about the different types of plate boundaries. First off, a divergent plate boundary. A divergent plate boundary is a tectonic boundary where two plates are moving away from each other and new crust is forming from magma that rises to the Earth's surface. When a divergent plate boundary is well developed, the seafloor elevates, causing an oceanic ridge.
When a divergent plate boundary is uplifting, it stretches the crust and makes it thinner. Along with the stretching, faulting, and volcanism form a rift valley. The next type of plate boundary is convergent plate boundary. A convergent boundary is an actively deforming region where two or more tectonic plates or fragments of the lithosphere move toward one another and collide.
These are the different types of convergent plate boundaries. To start off, ocean to ocean. Ocean to ocean is when two oceanic slabs converge. One goes underneath the other, causing volcanic activity that eventually creates volcanic islands.
The next type is ocean to continent. Ocean to continent is when a continental plate converges with an oceanic plate and sinks and melts into the magma.
An important thing that is formed at a convergent plate boundary is a subduction zone, which is when one or both of the tectonic plates is composed of continental or oceanic crust.
Trenches are also formed by subduction. And not only that, they also form island arcs. They are hot, remelted material from the subducting slab rising and leaking into crust, forming a series of volcanoes. Those volcanoes can make a chain of islands.
Subduction also forms volcanic arcs. They are a curved chain of volcanoes, an overriding tectonic plate of a subduction zone. Volcanic arcs form as a result of rising magma formed by the melting of the downgoing plate. The last type of convergent plate boundary is continent to continent. Continent to continent is when two continents are brought together by subduction and collide together, forming mountains.
The last type of plate boundary is transform plate boundary. Transform plate boundary is places where plates slide sideways past each other. A different kind of transform plate boundary is transform faults. Transform faults are plates that grind past each other without destroying the lithosphere.
Next, we are going to talk about why do plates move.
They move because of many things. First off, the intense heat in the Earth's core that causes molten rock in the mantle layer to move. Reasons this happens is first off, mantle convection. Mantle convection is the slow, creeping motion of Earth's solid silicate mantle rock in the mantle caused by convection currents carrying heat from the interior of the Earth to the surface.
Another reason is hotspots. Hotspots is an area in the mantle from which heat rises as a thermal plume from deep in the Earth.
Now we are going to talk about what plate tectonics shows us. First off, they show us geological structures. Geological structures is a study of the permanent deformation and rock failure created by the changes in stress through geologic time.
Geological structures show us folds and faults. Another thing plate tectonics show us is world volcanics. World volcanics have basaltic magmas which are formed by exceeding the melting point of the mantle either by adding heat, changing its composition, or decreasing its pressure.
It also has andesitic magmas, which are generated at convergent plate boundaries where the ocean lithosphere is subducted so that its edge is positioned below the edge of the continental plate or another ocean plate.
Another thing plate tectonics show us is earthquakes. Earthquakes are the shaking and vibration of the Earth's crust due to the movement of the Earth's plates.
Earthquakes have a shallow and deep focus. A shallow focus is earthquakes with focus nearer the surface of Earth. A deep focus is earthquakes with focus much deeper within the Earth.
Another thing that plate tectonics show us is mountains. The movement of the plate tectonics create volcanoes along the plate boundaries which erupt and form mountains.
The final thing that plate tectonics shows us is ocean trenches, which is steep depressions in the deepest parts of the ocean.
Thanks for watching. We hope you learned a lot about plate tectonics.